CoSentry is headquartered in Omaha, Nebraska. At this time we have 6 data centers throughout the Midwest. Midland's data center was commissioned in January 2010. This is our flagship data center based on a Tier 4 design. We have 10,000 square foot of data center floor. The power density is 150 watts a square foot. Tier 4 is based on the redundancy. Redundant UPSs, redundant power from utility, direct lines from separate utility substations, redundancy in your cooling, redundant chillers, redundant chiller paths, redundant electrical paths. So really the key word is redundancy. We have 2 direct lines from separate substations. Each is 13,800 volts with 12 megawatts. Then it goes to step-down transformers where we bring 2 4,000 amp 480 volt services into the building.
In the 4,000 amp entrance is also a paralleling gear. The paralleling gear is located inside the gear where it ties us in with being able to sync with generators to utility to do a seamless exchange of power.
We have 2 generators on site. One's a 2.5 megawatt and one's a 2.25 megawatt generator. Each generator has enough fuel capacity to run for 3 days at full load.
This is a remote power panel on our data center raised floor. This provides the A power source to all of our redundant feeds. And the B power source is on the other side of the aisle. So what we do is we provide a circuit out of the A side and a circuit out of the B side, and customers are allowed to plug into both with their dual cord equipment, knowing that if one side was to fail, the other side would always be available for them.
For 20 amp branch circuits feeding to the power racks, we have a minimum size of 10 gauge wire that's above what code is demanding. The majority of our circuits on the raised floor are 30 amp circuits, also above and beyond code. We go with 8 gauge wire. Grounding inside the data centers are very important because harmonics that are included in any type of nonlinear circuits, those harmonics can cause many issues with our UPS systems and with our battery systems. So if you don't have a properly grounded data center, you're going to have many problems throughout the years. Our grounding scheme starts from a main grounding electrode in our generator yard. Our external grounding is a deep earth electrode, which is then backfilled in light coil number 2. That is checked for a 4 ohm resistance, and it's an annual check that we do to assure that our resistance hasn't changed. We come into the building with a 500 MCM copper conductor, which goes to our main grounding bar. Each grounding bar after that is joined with another 500 MCM copper conductor. All electrical gear is grounded with a number 4 or bigger copper conductor going back to a ground bar. We do not allow a number 6, which is minimums by code. We have gone above and beyond that. On a data center floor, every 4 foot a pedestal is grounded. So we have a number 4 wire gauge bare copper underneath the floor that's in a 4 foot pattern. Each rack then is grounded to that 4 foot ground path. Each remote power panel is grounded to that as well. All the ground paths go back to one deep earth ground. You have to watch your dew point inside a data center, and that's really a lot of the reasons why we're also grounding these racks is to protect that sensitive equipment from static electricity. Our lightning protection system consists of antennas placed on the roof. Those antennas then go into a braided copper conductor, which is extended out to our main ground electrode in the generator yard. At no time do we connect with the building steel. We have 2 carrier chillers on site. Each chiller is a 550-ton water-based chiller. Once again, everything's redundant, so one chiller runs at a time as the other one sits idle. Each chiller has to be on its own electrical service. They cannot share any panels, so it's redundant panels feeding each device for the chillers, including pumps, water towers, fans. CoSentry provides uptime for all of our clients. Most downtime in data centers is human-related. To keep that from happening, we only choose contractors that can abide by the specifications we give. We have commissioning documents, and those documents help us to put together what our annual recommissioning process will be. That includes the grounding. We open up all of our electrical gear, we do infrared tests, we check connection, we do check the resistance of grounding electrodes. We also go through all the cooling systems. We have had issues where we had electricians that did not properly torque equipment. What we've done to remedy that is we have a torquing scheme. The electricians have to document every connection that they have. They have to document the torque setting. They also have to use a paint pen to physically mark the screw or bolt inside the lug and show us that it was done properly. We only use copper feeders, we only use copper lugs. CoSentry has a standard of copper connections only. We do not accept any aluminum connections. We do not allow this because aluminum is not a good conducting source. We do our annual retorquing, but with aluminum, I think I'd almost want to do a weekly retorquing. So we do not allow it. Everything in this building is copper only. There's many reasons to come to a co-location data center. The first reason is really cost. A lot of buildings have a facility group, but they do not understand the data center environment. That's what we do. We have a better working environment for data than what most companies can do on their own.